So, dear student, in the previous class, we have discussed the switchgear protection of a power system. So, basically, this power system protection is nothing but a subject what we are having after the several subject we have read in the power system. So, power system protection and a switchgear is the components which we use to protect our system during the fault. The operation of different devices is very fast. Basically, we want to operate for high voltage transmission line, that is for within 5 cycle. So basically 2 cycle is for the relay operation and 3 cycle is for the operation of the circuit breaker. We'll go through different devices like electromagnetic devices, digital relay, as well as fundamental principles of different relays in this unit, in this subject. And further, we'll also learn the different protection schemes applicable in the microgrid. These are the textbooks we have followed. Now, if you observe the power system we are having, so the power system we are having in the lower side, that is for distribution side, where we distribute the power at 440 volt or 11 kV or 33 kV. So these areas we are having, this is nothing but the area where we can distribute the power at a very low level of voltage. And most of the fault is detected by using a overcurrent scheme. Overcurrent scheme means what? We are basically using the protection equipment. So basically protection equipment, how it is operating, will require a relay as well as circuit breaker that will understand after some 2 to 3 slides. So in between this one, like in case of 110 kV also, we require that overcurrent protection. However, in the upper area where we are talking about the transmission system, where the transmission towers are there we use the distance protection. And before that, we'll be using the transformer. So transformer is connected to generator. So then generator and a transformer, there will be multiple relays are available. So multiple relays means overcurrent is also available. Then differential protection is also available. Then under voltage relay, under frequency relay, Buchholz relay is used in our transformer. So many things it will be there. So these are the basic structure of our system we have discussed. Then we have understood that power apparatus will be having two different kind of equipments are required. One is control equipment and second one is protection equipment. So when we are having a for failure of our protection, then definitely the burning and hazardous situation may come in our system. So for that reason, the power system relay should operate very fast in order to protect the our components like equipments after a fault has happened in our system. Okay. So we may try to understand that what is the reason of fault. Basically, we know that whenever the lightning strikes or the insulation has gone down because of the weather condition, we may see that there is a fault in our system. So further, in case of our transmission line, there are multiple fault may occur in our system, like three-phase fault, line to ground fault, double L fault, and others. We also have open conductor fault. But in case of current, when you understand the shunt faults, that is called, they are nothing but the severe faults. Our open conductor fault, when suddenly there will be open circuit, the power cannot be transferred. The voltage may go a little bit high because of the open conductor fault. So now we have understood the relays here. That is how the relay is getting operated. So we have three parts in this system. So basically, we are trying to understand that the relay is nothing but giving input to the input from the relay input from the CTPT. And when you are trying to understand what is the CTPT, so CTPT is nothing but refer to the sensors. So So basically in this slide, if you want to understand that what is happening in case of our relay system, so we are having a source which is nothing but the power which is coming from the generator, and it is connected to a bus. So what is a bus? The bus is nothing but even if you change the load from maximum to full load or the minimum to full load, the bus voltage is not going to change. So that is nothing but the bus we are having. So further, when you are having a fault in our transmission line, how the fault occur? Previously, we have discussed so transmission lines are there, and we are having the overhanging wires. So if the insulation of this tower it has fallen or has decreased or has flashover occurs in the insulation, then definitely fault will be cleared here. A fault will be created here. So this fault, if it is not detected as soon as possible, what is the time period? Basically, within 2 cycle to 5 cycle, that is the time period we are having. 5 cycle means basically, if you understand, that is 0.1 second. So 0.1 second is the time period where we have to dictate the fault and we have to disconnect it from the healthy section. So, and in this case, if you observe here that what we are having, how to sense there is a fault in our system. To understand there is a fault in our system, we also require sensors. So these two sensors we are having, that is voltage sensor and current sensor. It is we utilize to step down the voltage in by using a voltage transformer, and we utilize the meters in the secondary side of the CT current transformer, so that will sense there is a fault or abnormal condition in our system. So the input that is either current or voltage is given to the relay. So what is a relay? The relay is nothing but designed to dictate that there is a abnormal condition or fault in our system. So what is the abnormal condition? Basically, if you want to understand that there is a system, the system is having a operating limit. So that operating limit we are talking, this operating limit is nothing but the voltage, current, then frequency we are having. These are the operating limits are decided. If we are talking about a 11 kV system, so in case of 11 kV system, there must be a plus minus 10% variation of our voltage. In our current, if you observe, current may be plus minus 20% variation may occur. Frequency also may change plus minus 5% in our system. So when you understand that there is a change in voltage, current and frequency, and there because of this change, we are trying to understand that what are the changes may occur in our system. It may hamper our operation of our system. That is, the load may not be operating properly, or the system voltage may not be sufficient to supply the power. So for that reason, if you go beyond this limit, then immediately we have to take a decision to trip the circuit. How to trip the circuit, or how to disconnect the load from the source. So here we are having the circuit breaker. Inside the circuit breaker, what we are having a closed contact and a closed contact. Basically, the circuit breaker is nothing but a switch. Like we are having a switch in our home, or 440 volt or different MCB, these things are there. So this MCB, normally it is closed in our system. Whenever there is a fault in a system, it will try to open. So whenever it is trying to open, what is happening during this contact, within this contact will be having some flashover. So this flashover, what we observe, if it is not died out, if this flashover is not died out, then definitely you will see the hazardous condition. Hazardous condition means there is just flashover, or there may be a burning of equipment, like I have shown here that our in the previous slide I have shown that the transformer is burning. So this may occur because if the circuit breaker does not operate correctly to disconnect the faulty section from the healthy Okay, so for that region, when so when you so and so when we were discussing this overcurrent relay, so this overcurrent relay is also having these properties like dependability and security. So dependability means what? Whenever there is a system that is a source and a transmission line will be there. So and the fault occurs, then definitely it has to detect that there is a fault. But if there is a load change means what? Load change means the load has increased. Like I was giving an example in your hostel, we are having a plug point which is nothing but designed for 5 ampere. So 5 ampere means it may be a 5 ampere means it may be a load which is nothing but 100 watt 200 watt like that. So however, whenever we are going to plug a load which is nothing but 1000 to 1200 watt or 2000 watt like heater, as well as we'll be using other devices, so it will happen, it will draw more current like 10 ampere. So they'll be having 10 ampere plug or 15 ampere plug. So when you are using this 10 ampere to 1.2 kilowatt load in a 5 ampere plug, what is happening? The MCB is tripping. So the trip is happening because of the loss of security. Means you are losing the security in our system. Similarly, if the fault is not detected means there is a high resistance fault. Because of that, like if you're talking about the fault current, this is the source voltage, and we're having some reactance in the line, and the load is nothing but connected here, and the fault has occurred. So if we're talking about current, this current is nothing but equal to voltage divided by the impedance ZS. So if you see the impedance we are having, if this impedance is less, then what will happen? Current will be high. But if you're having a fault resistance, that is called resistance through the fault path is very high,